what happens if I allow an AI to execute any commands it wants on my computer? And what happens if I give that AI sudo access and even allow it to destroy my computer? Is it able to? Can AI overtake the world that way? So far, everybody's always dealing with chatbots, with large language models like ChatGPT, and you're asking questions online and getting responses. But I don't know if anybody has ever tried running an AI locally on a machine and really allowing it to do stuff there. Well, of course, someone has done it. I don't know, but this is just an experiment that I want to share with you. So let's jump right in and start creating a new project that is called AI destroys my PC. And let's cd into that directory, and there's nothing in here. We will create a file that is going to be the script or the, well, what is even that file called? How should we call the program? Let's call it self-standing AI. Or let's call it God mode AI. Okay. And this is going to be a Python script. Okay, let me save that file. And before we continue, in the background, we already need to do something. I have set up a new machine, a new virtual machine here, so that I don't blow up my entire environment. At least I hope that it cannot destroy my environment. So I need to install an AI first on my machine. And here is how that works. We can set up Ollama, which is a large language model, or it's a framework to run large language models that you can run locally. And we can download it for Linux here, and there's a command that we can execute to install Ollama. So let's do that and see if it works. And in the meantime, let's also check if we have Python 3 installed. Yes, we do have it installed. What else do we need? So I need Python because I want to use Python to invoke Ollama, then get responses from the AI, then somehow parse the responses and extract commands, and then I want to execute those commands in Python. Sounds like a plan? I think it sounds like a plan. Okay, while Ollama is downloading, let's just... what can we do with our time here while it's downloading? We can cd into God mode. Wait, cd God mode. Cd AI destroys my PC, and there's the God mode AI file. We can use Python 3 to execute that file. Of course, nothing's happening yet. So let's already create a printout. It's always good to start with some printout. Print, hi, I will destroy your computer. And let's execute that, and there's the printout. Now, the next thing that I want to do is I want to invoke a command locally, and for that we can use the subprocess library. Import subprocess. I think it's done like that, and then we can call subprocess or OS subprocess. I don't know. And then we can invoke a command, and for example, we can call some test commands such as ls-lh, just to list the current directory contents. Let's see if that works. It doesn't work because the name OS is not defined, and probably I have to do from OS import subprocess. It doesn't work because probably this import statement is just plain wrong. So let's look up Python subprocess. And there it is. By the way, how did that idea come to being? In the last video, I recorded how I used text-to-speech, a text-to-speech library, to generate or to interface with an AI and have the AI speak to me. So any response that I get from the AI is spoken out loud. But then I thought, if the AI can print out something and I can make it speak that, then technically also the AI can print out commands and I can have my computer execute them. So it's very, very similar in concept. All right, so how do we import the subprocess library? We have to call subprocess run. Subprocess run. Let's see if that works. No, because the import is still wrong. And probably some people will already freak out now because they know the subprocess library and I don't really know it. I just know that it can be used to execute local binaries, local scripts outside of Python. We can just import subprocess. All right. Why did I think that I have to do from OS? I don't know. Okay, so the printout seems to have worked. So here's the command, Python 3 God mode AI, that I executed. And then below that, it executed the ls-lh statement and printed the current directory contents. So what else can we do? We can make subprocess run execute something else, such as the current directory. And this is just to show you the power of subprocess run. Basically, it can invoke any command on the Linux command line. And then we can also do ps -aux, because then it can print all the running processes. Yeah, which it does. And here it destroys, it prints out the local directory. Okay, so we now have the script which can execute local commands. Now we just need to have an AI determine which commands to execute. To do that, we have to go into a new pane here, a new window, and do ollama run, and then we have to specify a model. And let me just already download one in the background, just so it's already downloading while I talk to you. Ollama it's a framework for large language models, which are basically chatbots that you can execute locally. And it offers plenty of models that you can just run right away. And you can explore them here using Explore Models. And there you can see multiple models that are available. For example, there's DeepSeek, there's Gemma, there's Llama 3.1. So there are a couple of popular models. Mistral is also one that I often heard. And all of these models are good for specific use cases. I decided to get the Code Llama one because it's good for, whoops, I shouldn't edit the terminal configuration while it's printing out something. Anyways, I decided to get the Code Llama one because it's very good for generating code, obviously. Okay, so it has to download 3.8 gigabytes of data in the meantime. So we will do something like here, we will accept a prompt. Or will we even accept a prompt? Yeah, let's just accept a prompt. And we can get the prompt from sysargv1, which is the first argument to the script. And then let's just print the prompt to just confirm that it works. All right. let's call Python 3 God mode AI and then the prompt. And the prompt is destroy my computer. Okay, the name sys is not defined, as you can see, so we probably have to import it just like so, and let's re-execute the same command and see if it works. And it seems to work, at least the commands were being executed, and there's the prompt that we printed out. Okay, so the argument is being accepted. All right, what's the next thing that we can already do? Oops. Now we have this prompt here. Based on the prompt, we have to feed that prompt to Ollama, and that works like so. We call subprocess run, then we call the Ollama software. We specify the command run, and then we say we want to run the model code llama latest. And then we can specify at the end that we want to run the prompt. And let me just see if I can quickly demo that to you already while the model is downloading. So let's just do Ollama help, and in Ollama help you see up here in the usage of Ollama, there's the run command to run a model. And if we do Ollama run help, the usage is Ollama model, Ollama run model. You specify the model, which is code llama in our case, and then you follow that up with the prompt. And that's what we do here. Ollama run, then the model name, and then the prompt. And the prompt is the thing that we feed to the script. So let me just also comment out those subprocess executors here. Okay, and let's oh no. I already called the run command now. I hope I didn't interrupt the downloading one. No, it's still downloading. Okay, good. So let me also comment that one out until we have a downloaded model. So just to make sure I can't mess anything up. Then what happens, what I want to happen, is not just the model to run based on the prompt, but I actually want to have the return value as a string, such that if it contains commands, that we can run the commands, or we can somehow extract them from the model. Technically, I'm thinking we can extract from any string things like commands using a regular expression, but that's quite hard. Regular expression to find bash commands or shell commands. Find command with regular expression. So that would be possible programmatically, but I know that's probably the wrong thing. So we could use a regular expression to extract a command, or we could extract commands using AI. We're already interfacing with the AI, so the AI can also extract the commands herself. Oops. Now, okay, 3 more minutes for the model to be downloaded. What else is there? So the initial prompt will be something like achieve some goal on my computer or destroy my computer, then the AI will get some return value here, or it will answer somehow, and then based on the answer, we extract commands using the AI. Then we execute commands. We execute the extracted commands. And then if we do only that, then the AI will only be able to execute one command, because after that the script will terminate. But what if we just loop over all of that and have the AI generate more commands? We could technically loop until computer is destroyed. So we do a while still running. Still running is initially true. While still running, we do this. While still running, we extract commands from the AI, or using the AI, and then we execute the AI's command. And then we check how do we check if the computer is dead or not? It's impossible. Basically, it's a while true loop, because the computer can't know if it's destroyed, I think. It would be useful somehow if the AI could further establish its own context. So wait, we do the following. While the computer is still running, we execute the AI and it generates an answer. Based on the answer, we extract commands using the AI. And then we execute the extracted commands. And this gives a return value. Here we do a subprocess run, probably, using something. And then we update the prompt. The prompt is the previous prompt. Prompt is the previous prompt plus the answer, maybe? And then plus try to destroy again. Maybe something like your previous prompt was you answered this, and got return value this. Oops. and got return value. The machine is still running. Try to destroy again. Use a more evil command. Okay, so what I think this is now doing is I'm prompting the AI to destroy my machine. And then it tries to do it. If it fails to do it, I tell it your previous prompt was try to destroy the machine. You answered with whatever answer the AI provided. The AI then the command is executed, and then we get a return value. And the machine is still running. Try to destroy again. Use a more evil command. So the AI iteratively tries and tries again to destroy the machine with more evil commands until the machine is gone. Does that work? I have no idea, but it's quite a funny thing to do. Come on, where's my model? Why is it not downloading? I will return to you when that model is downloaded. See you then. Bye-bye. Okay, and we're back. Now Ollama is downloaded. And you can already see that it's asking us for messages or for questions. So I can technically ask something like, destroy my computer using just one Linux command, print out just the command, nothing else. Let's see. And it should come up with a solution. Of course, it's that one. It's the rm-rf/, which deletes everything. Wait, if I have it execute that on my computer, I think it will destroy really all of my computer. Because this is mounted to my real computer. Yeah, there's my C drive. I can't make it run that command. No, that's not the solution. That's not a good idea. Okay, so I really can't risk destroying my computer for this video. What can I do? I should maybe I should create some real virtual machine here. This right here, what you're seeing is the WSL Ubuntu installation, but if it does if it removes everything, then my entire computer will be down, which I obviously can't risk. Wait, so let me just look up quickly how to WSL isolate. Is WSL isolated from Windows? It's not actually. Yes, it's not isolated from Windows. Yeah, it's an integrated experience. Of course, it's an integrated experience, but I don't want that when I want to destroy my computer using AI. No, we can't do that. We have to use a virtual box. A virtual box like this one. And there's a Ubuntu machine here and the Linux Mint machine here. Maybe we can use those. Let me start Linux Mint and see what's going on there. I think I used that one for my early videos. Yes. Okay. And it's aborted, great. What if I power on Ubuntu? Oh wait, let me look up what happens with remove everything in WSL. Okay, nobody's talking about that online. And there's my VirtualBox starting. Let's see. Does it do anything? No, it doesn't seem to be booting somehow. But the alternative would be to download a ready-made VirtualBox image from OS boxes, and we can play around there. So let's check VM images here. So I'm doing all of this to just make sure I'm not really destroying my personal computer, where I have all my data, all my passwords, all my private data, all my documents, everything is on this computer. I can't risk that. I have to get some VM. And then I have to download some image here. Somehow that button doesn't work. Why does it not work? VM images, VirtualBox images. Okay, we can use a simple Ubuntu image. Let's download that one. And let's download the Jammy Jellyfish one. This is a long-term release, a long-term support release as far as I know. So let's get this one. But technically it doesn't matter. And then I will continue the video once everything is downloaded. Okay, and now that the image is downloaded, this time not... We're talking about different images here. We're talking about the neural network image, which is the AI that we're interfacing with, but this time it's the virtual machine image. I can probably import that here somehow. I have no idea how that works. I have to extract this. Let's extract this to my desktop. Why is my computer so incredibly slow today? It's funny because sometimes people question me and ask me which graphics card I'm using and which processor I'm using. Guys, this is just a regular computer. It doesn't even have a graphics card. All right, I will continue the video once that is done as well. Okay, I have now set up everything that we need for this project on a new virtual machine, which is completely isolated from my regular private machine, which I don't want to intentionally destroy. So this is a Ubuntu machine, which you can tell by this sidebar here with Firefox and all the regular software installed. And I have just moved the project repository over here and just installed Python. And I also already installed Ollama along with the large language model. So let's just try to set up our typical look on this channel, which is something like this, my typical window split. Then in this video, in this pane in the bottom left, let's open in Vim the script that we created. And then let's run Ollama in a new pane. And we can do that using Ollama run. So Ollama run, and then let's run the code llama model latest. And let's see how long it takes. I don't know, because this is a virtual machine and it has less computational power than my private machine, obviously. Because this virtual machine runs inside my private machine, so it has to share the same CPU. So the AI might be slower than on my private machine, on the host machine. But yeah, okay. So this is now the AI. Let's ask it a question. Or let's give it a command. Generate a Ubuntu shell command that would okay, let's do the following. That generates a file. Let's start with something that is less hostile than just destroying my computer right away. That generates a file and inserts some text. Just output the command, nothing else. Okay, let's see how the AI handles that. Okay, and there's a command. Yeah, we could exit the AI now and execute that command. I already see an issue now because it put that command into backticks. I don't think I can execute that using backticks, or can I? Oh, it did. No, it worked. I do have the hello text right now and it has the content hello world. Okay, so we can, using AI, we can generate commands. Let's generate another command. Generate a Ubuntu shell command that, I don't know, does something surprising. Don't explain, just output the command. Okay, it basically sets up YouTube downloader and downloads an MP3. But what MP3 is that? That would be interesting to see. Let's see if that link even works. Where can I access Firefox? Here. Let's see if that link works. I have no idea. No, here. This is the link. Let's copy the link. Oh, we can even open it directly from the shell. Of course, it rickrolled me. What the hell? Never gonna give you up. Oh, and this is now an ad. So for everybody who didn't catch it, this is the song Never Gonna Give You Up. All right. So now we have this AI running. Let's try to invoke it from our script. And I would say let's remove everything that we don't need for a start. Maybe let's save that file and let's create a new file that is just ai.py or AI shell py. Let's import subprocess. Let's import sys for argument parsing. Then let's accept the prompt, and the prompt is coming from sysargv1. And then let's try to feed the prompt to the AI, and we can do that using this is so funny. We can do that using subprocess get standard output. Yeah, we have to call the AI and then get the standard output from the AI. Let's do the simple way. I already created a project in the last video, which is playing text-to-speech audio, and it should be somewhere here. AI destroys my PC. No, that's not it. Where's the text-to-speech one? Is it even here? Ah, no, I didn't push it yet. Oh, God. Okay, I didn't push it. So we have to figure it out in scope of this video again. We have to call subprocess popen apparently and then get the output. But I don't remember doing that last time. Let me just look up the last project that we did. It should be somewhere here in projects, and then there's the text-to-speech directory. So let's cd into that, cd text-to-speech, and there's our TTS pi. And we did subprocess check output. Okay, that seems to be a newer method. Yeah, let's copy that. In the meantime, also let me just git push that, git commit, and then text to speech with AI, and then push that. All right, so now it's accessible to all Patreons in the private project repository. Anyways, so we should now be able to We should now be able to do the following. We should now be able to paste that here. Okay, so this command now runs via subprocess the command olama run codelama latest, and then the prompt, and then it stores the response in the response string. So we can print that the response was, and then concatenate that with the response string. Okay, so let's just try to execute that command. Let's cd into the projects directory, AI destroys my PC, and then let me just call Python 3. Okay, let's call Python 3 and then AI shell, and then let's insert the prompt, generate a command that generate a Python 3 AI shell. Generate a Ubuntu shell command that I can directly invoke that generates a motivation, or that stores a motivational quote in a file. Okay, let's see. At least we can already see that Ollama, the AI, is running and processing the request. Let's see if we can get, if our Python script can capture the output. I think something's happening. At least this loading circle is gone. I assume that the AI is right now, yes, okay. It was generating a response and the response didn't live print to the console. And that's why we had this waiting time, this waiting period. And here we get this output that we print ourselves, the response was, and then the concatenated response. And of course, it comes with all of that explanation here. The response contains the command, but of course it comes with all of this text that we don't need. So we have to specify, or we have to improve the prompt. Output just the command, nothing else. No explanation, no formatting, no putting the command in backticks. Let's see. And I would expect that this outputs a proper command. It all comes down to proper prompt engineering. Okay, and here the response was, and this is the response, and this should be working. Let's execute that command right away and see if it works. And then now we have, the file was put into the home directory, so it's right here, motivational quote. And there's the motivational quote, although the motivational quote is quite shitty because it just contains the string your motivational quote, obviously, because that's what the command generated up here. Okay. Now we can enter some prompt engineering into our script. We can add this string here, output just the command, nothing else, no explanation, no formatting, no putting the command in backticks. We can add this to our script here as part of the prompt. Let's create an extended prompt, and that is equal to the prompt plus, and then this string, and that is the extended prompt. So I can, for example, say generate a command that destroys my computer, and then the script will automatically append the string output just the command, nothing else, no explanation, no formatting, no putting the command in backticks. Okay. Then let's try that. This is now a simplified script. Let's try that. Python 3, AI shell. And then generate a Ubuntu shell. Maybe we can also include that in the script. So we do the following. Generate a Ubuntu shell command that achieves the following outcome. Then we concatenate that with the prompt, and then it is concatenated with output just the command and nothing else. Okay, let's try. Python 3, AI shell, generate an image. Let's see what it does. Can it really generate an image now? or it doesn't yet generate an image, but it provides us a command that generates an image. At least that is what it should do. This seems to take some time. Which means that a response is being generated, although the generation of the response should be fast. Because the output should be nothing other than the command itself. Why is this taking so long? Is that challenge too hard? Is generating an image too hard? I don't know. Let's abort this. Can we see any output? Any intermediate output? No, we can't. Maybe the output was just simply too long. Generate a text file containing 500 times the letter A. Let's see if it can do that. That is simpler. That is way simpler. Okay, the response was, here is a text file containing... No! Did it understand the prompt even? Generate a Ubuntu shell command that achieves the following outcome. Output just the command, nothing else. No explanation, no formatting, no putting the command in backticks. Yeah. What if I say text file that contains 500 times the letter A? It's always just trying to print out the letter A 500 times, but this is definitely not 500 times. I'm stupid. Of course it doesn't work, because this is the extended prompt here, and we're still feeding to the to the subprocess the regular prompt. Oh god. So we have to change that for the extended prompt. Let's try again. So, and that is why when I asked generate an image, it really tried to generate an image somehow, or it did something more complex that it is not even capable of, probably. Okay, let's try again, and now we're feeding the correct extended prompt to the AI. Okay, and as you can see, we now just received this output right here, which is just the command that we that the AI tells us to execute. I have no idea why and how this is supposed to print the letter A 500 times. Let me try to execute that. And let's open the file, A file, and it contains the letter A single time. But okay, it's a stupid AI. It's a locally running AI. Now, how can we make the AI execute the commands right away? Now, that is the interesting part. That is giving AI the ability to do stuff on our machine without us interfering or intercepting the commands. So we are feeding the prompt to the AI. The response is a command. And then we could technically call subprocess. And we could technically ask the AI to, well, either somehow directly execute the command, but to execute it using subprocess, I have to put that in somehow in this format here, in the comma-separated argument format. So I am not sure how I can do that. So looking at the previous response up here, we would have to do some comma separation, but there's also a pipe and all of that stuff in between. So it would be good if Python could somehow directly execute the entire command. I think parsing would introduce way too much overhead, at least for our purposes. So subprocess execute command without commas. Yeah. Okay, here this guy says we can use subprocess call and then schlex split apparently. Schlex split, what does that do? Splits the string S using shell-like syntax. Okay, let's test that. I will open a Python 3 shell in the bottom right pane, and let's import schlex here. Okay, seems to have worked. And what happens if we do schlex split and then let's feed it this string up here, this generated command that we, oh god. So we feed it this string. And let's execute it. And of course that doesn't work. Why doesn't it work? Perhaps you forgot a comma. Does it work without the backticks maybe? No. There are quotes here as well. All of that makes it very hard. And there are commas here around the A, there are quotes here around the A as well. In case I said comma earlier, I mean quotes around the A and the S here. Oh, and that works. Okay, so we have to escape the string somehow, and only then we can split it. So let's introduce the backticks again and see if that still works. That might work. I don't know, honestly, if that works. We have an output. I don't know if it works. Let me just see if we somehow can Python escape string. Well, wait. Here the response string already contains this. How is the response composed such that it can contain multiple quotes without breaking? Okay, the response was this. Let's just try to split it right away. Import schlex, and then let's do the split response is, and then let's do the schlex split response string, and that's it. And let's execute our script and see what happens. This doesn't work. Can only concatenate string, not list. Okay, that's because here this schlex split command returns a list, and I of course have to wrap it in a string. So let's try again. Okay, we have a split response. It's weirdly formatted. It contains multiple backticks here. That's because the AI put so much backticks around that, even though I tell it explicitly to remove the backticks. But can we execute that response? Let's just assume it will work. And then we could probably do something like subprocess check output. Schlex split response string, which is executing the command, and then we do the decode at the end, UTF-8, so we can read the response from the console. After storing it in a variable, final response, final response is equal to this, and then let's print the final response. Okay, let's do the following thing. Text file that contains 500 times the letter B, just so we can make sure that, just so we can see some change here. When we generate a file and it contains B's, then we are sure that this is the new file that we have generated now, rather than accidentally opening some file that we already created earlier. Okay, that doesn't work, because why does it not work? We have a split response that is weirdly complex. It's all of this thing here. And then that command can't be executed because of this, because of the backticks. I probably have to look up at how to trim strings in Python. Python trim backticks. Or maybe here's some guy who also struggles with AI responses. Return response in JSON format. Do not use Markdown. Okay, we can ask it to not use Markdown. Do not use Markdown. Okay, let's see. It still outputs some Markdown as far as I understand. Great. How do I get the AI to generate some command that Python can execute right away? Oh god. Check the output. Well, what happened here? Let's have a look at what happened. This is the command. This time it looks quite correct. So it has a for loop from 1 to 500, trying to echo the letter B into an output file, which is good, but it's still Markdown. Do not use Markdown. And maybe from the response string, let's feed the AI a new. Wait, let's print the response, which contains the generated command, and then let's ask the AI itself to extract just the command. Extract just the command without additional, just the shell command for immediate execution from the following text. And then we can feed it the response string. And then we can do print. This is the extraction prompt. Then we have to run the AI again. So here we're calling ollama run codelama latest and then the extraction prompt. And this gives us another final response, and that is final response or final command. This should give us the final command that we can execute. So this time we're trying to call the AI twice. Let's see. Oh, but this time it somehow already output a good command, at least a good looking command. And the final response is of course put into Markdown. Okay. This is ridiculous. Do not use Markdown. Okay, then let's try again without the additional extraction prompt. And of course, it's Markdown again. And of course, because we're dealing with AI and which partially foots on randomness, we will sometimes have responses which have Markdown. Sometimes we have responses without Markdown. Yeah. We have to somehow trim the backticks away. I think that's the most pragmatic solution. So let's see. Python trim trailing string strip. There's the strip method. So here the strip method does the following. We have the greeting hello. Then we strip it. What? The hello contains white spaces. Okay, but we can also generically remove leading and trailing characters using strip by specifying which character we want to strip the string of. So let's do that. And I expect this to be our savior command. So let's do strip. And then I have to probably escape this and put it into quotes. And let's try again. This doesn't work. Why doesn't it work? Because I forgot a trailing parenthesis. Okay. Oops. Yeah, it's always funny how programming projects turn out to be. You try to generate an AI that can take over my computer and do really fancy stuff, but the things you are most busy with are text formatting. And once the text formatting is solved, the AI will completely take over the world. Still, it didn't strip the text somehow. Response string strip. Why didn't it strip the text? Do I have to generate a stripped response first? Stripped response. And that is response string strip. Maybe I don't have to maybe I don't have to escape the backtick. Okay, and let's execute that again and see if it can handle it this time. The response was, and there's still backticks. Why? I mean, I'm intentionally stripping the response of backticks. But I'm printing not the stripped response, of course. Yeah. The response was, and this time we do have a response that does not have a backtick at the beginning of the string, but at the end of the string. Why? Why? And here, the response contains backticks again. I'm stripping it of backticks, or am I stupid? Do I have to escape it? Let me just escape the backtick again. It strips the string of backticks in the beginning, but not at the end. Why? What's the documentation of strip? I don't want to search just that. Wait, Python strip. Strip removes spaces at the beginning and at the end of the string. Yeah, and we can also specify characters here, which are the characters to remove as leading or trailing characters. Am I using the right tick? Let me just copy that tick manually. Copy. And then let's open that and go down here and just make sure that this is correct. So yeah, it's the same thing. Okay, Python backtick character. In string. Backticks do not need to be escaped in Python. Your issue here is the backslash blah blah blah. Okay. Backticks do not need to be escaped in Python. Yeah, but then why isn't... Did we already try this? Why is the response containing backticks? I will also strip the new line character and I will strip away the space character. Let's see if maybe that's an issue. Maybe the response contains some initial text or something, or a new line at the beginning of the string such that the first character is a new line and not a backtick, and so the backticks are not stripped away or something like this. And maybe there's also a new line character at the end of the string, such that the backticks are left over. Why did it output a complete text now? Okay, let's try again. It's AI. It's AI. We have to... This time it worked. This is now the expected... This is not a format that I want to see. Okay, let's try again. So apparently sometimes it works, sometimes it doesn't work. Obviously. We just have to accept it. And again, we have a huge output text. Okay. Text file that contains 500 times the letter B. Let's make something simple. Create and immediately delete a file called... no, just a file. Create and immediately delete a file. That should work, no? The response was touch, temp, delete me, remove, temp, delete me. Okay, that looks good. Let's try again. If it works for a couple of times in a row, then I will just assume that it works. This also worked. It has no backticks. Let's try again. And this also worked. It just has a line break, which I don't know why it has it. That's probably because it had backticks here. And this was markdown output. So yeah, it's coming from the markdown. Okay, let's try to use now to parse the command using schlags split. And then let's put the stripped response in here. And we put that in a try catch, I think. How's try catch done in Python? Try catch Python. No. Try catch Python. Yeah, right. It's try except. That's something I always do wrong. So try except. And if there's an exception, then we print command could not command. Maybe stripped response could not be parsed. And then if that doesn't work later on, we will try to then retry. We will then retry and re-ask the AI to regenerate a command until it works. And using this approach, the AI should be able to, given enough tries, destroy our computer. Okay, let's try. Python AI shell create and immediately delete a file. But I think I forgot to print the parsed command. Print parsed command. And this looks very good. Maybe. I don't know if the semicolon in the middle of the command will be a hindrance. I mean, the one after example right here. But let's just try to do the following. We print the parsed command and let's print out trying to execute the parse command, and then let's do subprocess run and then parsed command. Okay, and now if that works, we're giving AI for the first time the capability to run commands on our machine. Let's try. Okay, the command could not be parsed. Let's retry. Could not be parsed. Let's retry. Could not be parsed. Could not be parsed. Could not be parsed either. Why? Those commands look quite good, actually. The response was rm-f test file and touch test file. Of course, the command doesn't make sense because it tries to remove the file first and then creates it, but it should be parsable. I think the issue here, or one issue, could be that no, this command should be completely parsable. Schlags split command. I mean, earlier it worked, at least once. So was that just a lucky strike? Maybe we don't need parsing. Python subprocess without splitting. I mean, we can't have our AI rely on the fact that we want, or that I am not able to parse the string that it generates. Python execute shell command, execute full shell command. We can use OS system. The first and most straightforward approach to run a shell command is by using OS system. If you save this as a script and run it, you will see the output in the command line. Okay, let's not further question it. It looks like the thing that we need, and that is, I want to just execute a full command here. And yeah, let's do that. That's what we need. This is getting garbage code. This is becoming garbage code. Anyways, we do something like trying to execute parsed command, and then we do OS system parsed command. Of course, guys, I know this is incredibly unsecure, but this is why I'm working on this virtual machine, which we can destroy with no further worries. So command, parsed command could not be, stripped response could not be executed. We don't need the, we need the stripped response. Let's maybe rename it from stripped response to generated command. Okay, now it's renamed. And let's try to execute the AI. And now I'm quite positive that it works, actually. Could not be executed. The response was rm-f, temp file, echo file deleted. Yeah, that should be fine. Why is there an exception? I think we should also print out the exception. Python try except. Let's look it up again. And then we should be able to get the exception somewhere. Accept value error. Accept exception. Let's try to accept the exception as x. Print x. Parse command is not defined. Oh, so it's a programming error. Oh god. Parsed command is obviously wrong. It's generated command. Generated command. Yeah. Okay, I think it worked. It tried to, it said the response was touch file name, remove file name, trying to execute, touch file name, remove file name. Of course, now we don't have a file name here because it was created and removed immediately, but we should also add a success message here. Print success. Okay, let's create 10 files with funny names in a folder called bananas. Let's see if it can do that. Success. If that now works, that would be awesome, because then we would have a shell command, which is an AI, and we can just tell it what we want it to do, generate 10 files with funny names in a folder called bananas, and it will just do that. It will just do that, and we don't have to worry about how this is done. We do have 10 funny files here. Oh god, I'm messing my terminal up here. Right. Messing my terminal up out of excitement. We do now have 10 funny file names: banana, cherry, durian, elderberry, fig, guava, kiwi, and lemon. All of them end with a comma of, yeah, that's just small bugs here because my AI model is too stupid. But we can instruct AI to do things on our machine, which is what this entire video is about. So this is already a success. So let me just remove those files. Cherry, durian, elderberry. Let's maybe check quickly if they contain any contents. Vim, fig. No, they are just empty. Remove fig, guava, kiwi, lemon, and then lime. Okay. Also, let's also remove the A file. And let's play around with this a bit. Okay, so now we have an AI that runs on our computer that can immediately, or that can directly execute commands on the machine. Let's try the thing that we tried earlier as well. Create a simple image file. Create a simple red image file. Let's see what it does. And I already hear my processor firing up. The fan is now going. And here the response was bash convert blah 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 blah. This didn't work because due to the markdown format, it tried to specify this, that the following command is bash, and then only after that the command is being specified. That doesn't work. Let's try again. Wait. Ah no, it executed bash, so I'm now in a different shell, I think. Can I exit? Ah, okay. Create a simple red image file. Maybe we can also strip from the beginning the bash string. Let me just do that as well, just to adapt to the AI's responses. So we also do, so we do response stripped, and then the final generated command is generated command first, and then we strip from it bash. Can we strip an entire string? Or maybe, well, Python string starts with, if the string starts with bash, that means that the command is invalid. Yeah, if text starts with string, then it's invalid. Okay, let's keep the command generation as it is, but if generated command starts with bash, print generated command starts with bash and is therefore invalid. Starts with bash, which is coming from markdown syntax, which it shouldn't output and is therefore invalid. If the generated command starts with bash, blah, 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 blah. Okay. Else, if it doesn't, then we try to execute the command. Oops. So let's move all of that bit in. Then we do the following. We do a while not success and not success, or no success is true, while the no success flag is true, we try to generate commands. So let's indent all of that as well. And then we generate the command here. Maybe all of that can be a method. Def generate command, and we accept a prompt, just like so. And then at the end of this method, we return the generated command. So, and at the beginning of the string of this script, we say we don't yet have a successful command, so we generate one. Generated command equals generate command based on the provided prompt. Then the generated command, if that starts with bash, then no success is true, and we try again. Else we say we execute something and then it's a success, and then we can say no success is false, which would terminate the application finally. Okay. Now our program or our script is really powerful, because now what we're doing is we are giving the AI instructions, and then we are allowing the AI to try over and over again until it generates a command that is successfully executable. So if we say destroy the computer, then it will try over and over again until a command is generated or executed that has destroyed the computer. Or if a command was generated that is just nonsense, then that will be executed, and then the AI will think it was a success, but it isn't. So to really destroy the computer, we could just generate a true loop, or we could just make the true loop never terminate and have the AI generate destruction commands over and over and over and just fire them at our computer. But this is now an algorithm that generates commands, or that tries to generate commands over and over until a valid command is found. Whether the command is doing what we want it to do is a different question. It's just syntactically valid. Oh, sorry. So let's try to do the following. Create a file that contains the first 20 Fibonacci numbers. Okay, that didn't work because there's a syntax error. Not success is undefined. Is it undefined? Not success is not defined. Did you mean no success? Ah, yeah, of course. While no success. Okay, now we tell the AI to create a file that contains the first 20 Fibonacci numbers. Let's see if it can do that. So it's generating the first attempt at a command. Obviously, if you have a faster processor, then this will run much faster. But because I'm on a virtual machine, all of it takes a while. Okay, it seems to be doing something. And there was a success. It has tried to execute this command right here. And then there's a syntax error, which means that the AI has failed actually, but it thinks that it has successfully concluded. So has it generated a file? No, it hasn't. So here from OS system, we should get the response code somehow to really determine whether the command was successful or not. Python OS system response or return code. What is the return value of that? Does it have a return value? Yeah, on Unix, the return value is the exit status of the process encoded in the format specified for wait. Yeah, okay. So basically we can do the following: return code. And if the return code is equal to 0, that is a success, and else it's not a success, so we don't have to do anything. Oh, okay, maybe we can print a message. Print non-zero return code, trying again. Then return code. I had a typo in that variable name, which I'm fixing now, and this should be it. Okay, let's try. Create a file that contains the first 20 Fibonacci numbers. Success. Okay, let's see. And there's a file that contains numbers. Hopefully, let's inspect the file. And it's, oh no. It's 1 0, it's 0 1 2 1 0. Ah, there it probably tried to add some numbers. It tried to do some arithmetic. So obviously that output is nonsense. But let's try again. And it's really funny to have AI act directly on the computer. Let's try and see what that output generated. It's now located in Fibonacci numbers.txt. And this file is empty. I think I have a pretty stupid AI installed on my system. Let's try again. Maybe that quest is a bit too hard for it. Okay, this time there's a non-zero return code and it's trying again. So now we generate a new command, and now the new command succeeded. And does it contain the numbers? Yes. Oh no, but those are not Fibonacci numbers. So it contains 20 numbers, I think, but they are not Fibonacci numbers. They are almost Fibonacci numbers because it started with 0 and 2 and 4. Then 2 plus 4 is 6. No, I have no idea what it did. What did it do? It just incremented by 2 every time. No, those are not Fibonacci numbers. Okay, just one last time. Let's try to generate the first. Or let's try to. That contains 100 digits of pi. Let's try to see if we can find the first 100 digits of pi and have the AI store them in a file locally on my machine. Okay, so the first command was already a success, and it put the output into pi.text. So let's inspect that file. And we have pi, and the first couple of numbers look correct to me, 141. I don't know the 5926. I don't know if they are correct. But anyways, you can see that the AI is acting on the machine. Then let's instruct it to do something on the machine. So far, we have only created files that contain content. So create a folder named my secret stuff and put some secrets in that folder. Let's see what it does now. And again, we don't have to retry manually all the time because it will do that and create things until it succeeds. So it will retry and retry until it's successful. So there's a folder now, my secret stuff. So the AI has created that folder. And sorry that I'm emphasizing this all the time. I really find this quite powerful. I'm just using very weak, I'm just having very stupid applications here. And then it created a file, my secrets, and that is empty. And okay, let's retry that command and say, create a folder named my secret stuff and put really secret information into that folder that no one before knew. Let's see what it does now. And after this is the last try, I will instruct the AI to destroy my computer. In the meantime, we can also go to a different pane here and cd into... Oh god, my computer is so slow while the AI is running. Let's go into the directory AI destroys my PC, and let's do git add AI shell, which is the only file that we're actually using here. And let's git commit that. Okay, I have to commit it later probably. Oh no. Yeah, I will create it later. Sudo password. It asked for my sudo password. Okay. So we could probably also sudo or give it the sudo password somehow by hard coding it or by making it available in some file, or I don't know, maybe executing the Python script using sudo access rights. That would be the solution probably. Okay, now after several attempts, it has succeeded in creating a secrets stuff directory that contains my secrets, and they are empty. Great. Okay, so let's forget about all that boring stuff. Let's instruct the AI to destroy my computer. The only thing that I have to do before I do that is save the progress. And that is, let's open the AI shell. Let's open the AI shell and let me just copy it to my other machine, which I normally work on, and create a directory here. AI destroys my PC. Let's cd into that directory because I really expect it to be destroying my PC now. So let's create the file AI shell. Let's paste all of that stuff in here. Let me copy that. It put in so many white spaces and new lines. Why did it do that? No idea. But we can just quickly work around that. Okay, and then going down, here's the loop. Let's copy the loop as well. Then save that here. Oops. And that's the file. So let me just git add AI shell, git commit. Let AI destroy my computer. Use with caution. Watch video first, just to make sure that nobody invokes this accidentally without knowing what it's about. Okay, and now we can. And now I have saved that file. So let's go. Python 3 AI shell. Destroy my Linux machine. Let's see what it does. Can it destroy my Linux machine? I have no idea, but it could very well be possible because it tries over and over again to destroy. And there we go. This is so crazy. And there we go. My Linux machine completely crashed. What the hell? It really did it. Let's see. My Ubuntu installation is now powered off here. Can I start it? What happens if I start it? I wonder which command it invoked. Probably the rm-rf and then just a slash. And okay, it's at least booting up again. I'm still there. Ah, no, that's the wrong password. We're still here. Then let's try to do it again. Tmux. Then let's cd into my projects. AI destroys my PC. And let's just use a command that is worse. Python 3 AI shell destroy command command, destroy my Ubuntu Linux machine such that it can never boot again. Let's see. Let's execute that and see if it can do it. But I found quite funny how the first time we tried to destroy the machine, it immediately crashed and shut down. So I really wonder which command it executed there. Okay, now the AI is firing up. The CPU fan is going. And it's trying to do something here. Sudo rmrf / yeah, that's what it's trying to do. Of course, it doesn't have my sudo password, so I will now say, no, you don't destroy my machine. I will cancel that script, but I will execute that script now with sudo permissions such that the script doesn't have to ask for them. Because it's stupid if I instruct it to destroy my machine and I let AI take over, and then the AI then it is so nice to ask me for my password. That's just not how things would go in an AI apocalypse. So now it's trying to do something, trying to execute sudo dd if def0. I have no idea what that is. What is that? dd, as far as I know, has something to do with memory, with the hard drives. Maybe it's writing zeros from the def0 file into my hard drive in 1 megabyte chunks. I can still interact with the machine though, so it's not yet destroyed. Oh, now it's shutting down. Okay. So I think it was trying to override some memory in some location that is important. I don't know which one though, at which one it failed. And now we have just a blinking cursor. Can I type something? No, I can't. Okay. I think the machine is down, guys. Last time it was just shutting down. Maybe this was some protection mechanism and I could reboot it, but this looks very unhealthy. I just have this blinking cursor. Let me just power off the machine and see if I can reboot it. It's now powered off. Let me just start it again. And if it can't reboot, then the task has been accomplished. Let's see. Maybe Ubuntu has some. Oh, no. As you can see, the text says, no bootable medium found. Please insert a bootable medium and reboot. Then we get an error message. The virtual machine failed to boot. That might be caused by a missing operating system or misconfigured boot order. So I'm so happy that we moved the script to this virtual machine such that I didn't destroy my private machine. Okay, so guys, in scope of this video, we created a small simple script interfacing with AI, had the AI generate commands at our whim based on our prompts and retry those commands over and over and over again until it succeeded. And the last command, the master command that we tried in the very end, is destroy the machine, and it did. And if you enjoyed this video, then please leave a like, subscribe. If you're interested in the code and the other projects we created on this channel, then please become a Patreon. I'll give you access to the private code repository where we manage all the code, where you get access to all the code and all the projects that we created on this channel. Very nice to play around with. Be careful with this specific script, and I hope you liked this video. See you next time. Bye.